Hello everyone. In this video we are going to solve the problem number 1.42 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A particle moves along the plane trajectory y as a function of x with velocity v whose modulus is constant. Find the acceleration of the particle at the point x is equal to 0 and the curvature radius of the trajectory at the points if the trajectory has the form. In the first problem it is given that it is the parabola, and in the second problem it is an ellipse. Okay, so let us say that this is the x-axis and y-axis in the xy plane, and the point in this particular plane in which the particle is moving according to the trajectory, that is parabola and ellipse. Let us say the point is x comma y, and this is the radius vector. So the radius vector we can write it as xi cap plus yj cap. Okay, and we have to find out the acceleration. For that let us differentiate it. So we will get velocity vector is equal to derivative of the position vector with respect to time. So we will get dx by dt I cap plus dy by dt j cap. Let us differentiate it again. So we will get the acceleration vector, and it is represented by w vector, that we can write it as dv upon dt, that we can get d square x upon dt square I cap plus d square y upon dt square j cap. Okay, and in the first problem it is given that the equation of trajectory is parabola, and it is given as y is equal to ax square. Okay, so let us differentiate this particular equation with respect to time. So we will get d by dt of y is equal to d by dt of ax square. So the derivative of y we can write it as dy by dt is equal to a times d by dt of x square. So from here we will get a times 2x into dx by dt. So we can get dy by dt is equal to 2ax times dx by dt. Okay, so this we have got. Now it is asking to find the acceleration at the point of x is equal to 0. At x is equal to 0, we can write dy by dt is equal to 0 because here x is 0. Okay, now let us differentiate it again. Okay, before that let us write the velocity vector. So we can write the velocity vector as dx by dt I cap plus dy by dt j cap. Here dy by dt is 0 as we have found out here. So velocity vector at x is equal to 0, we can write it as dx by dt I cap, and if we write the magnitude of this particular velocity vector at x is equal to 0, that is constant at every place, and it is given as v, that is equal to dx by dt. Okay, so dx by dt is v. Now let us differentiate this particular expression again in order to find the acceleration. So we can write d by dt of dy by dt is equal to d by dt of 2ax times dx upon dt. Okay, let us differentiate. So here we will get d square y upon dt square equal to, here we will apply the chain rule, 2ax as it is, d by dt of dx upon dt plus dx upon dt as it is, and here we will get d by dt of 2ax. So we will get 2ax times d square x upon dt square plus, here we will get dx upon dt as it is into 2a times dx upon dt. So finally we will get 2ax times d square x upon dt square plus 2a times dx upon dt whole square. So this is the expression of d square y upon dt square we got. Now we know that dx upon dt is constant and that is equal to v. So if we differentiate this particular expression, then we will get d square x upon dt square is equal to 0 because velocity v is constant. Okay, so that means this term is 0. So we can get d square y upon dt square is equal to 2a dx upon dt whole square, and dx by dt is given as v. So finally we will get d square y upon dt square is equal to 2a v square. So if we write the acceleration vector, that we can write it as d square x upon dt square I cap plus d square y upon dt square j cap. Here d square x upon dt square is 0, so this term is 0. So we can write the acceleration vector as d square y upon dt square j cap, and the magnitude of the acceleration vector, let us represent it by w, that is equal to d square y upon dt square mod, and that we can write it as 2a v square. So this is the expression of acceleration we got. Now in the second part of this particular problem, it is asking to find the radius of curvature. For that we will use the formula, that is radius of curvature is equal to 1 plus dy by dx whole square whole to the power of 3 by 2 whole divided by d square y upon dx square. Okay, and we know the trajectory is y is equal to ax square. Let us represent y with respect to x, so we can get dy by dx is equal to 2ax, and then if we differentiate it again, then we can get d square y upon dx square is equal to 2a. Let us substitute the value of dy by dx and d square y upon dx square in this particular expression. So at x is equal to 0, dy by dx is equal to 0 because x is 0, and d square y upon dx square will equal to 2a. So we can write radius of curvature is equal to 1 plus 0 whole square to the power of 3 by 2 whole divided by 2a. So we will get radius of curvature is equal to 1 upon 2a. Okay, so this is the value of radius of curvature we got. Now let us talk about the second trajectory. When the particle is moving in an ellipse, then what is the value of acceleration and the value of radius of curvature? So that what is the equation is given, x square by a square plus y square by b square is equal to 1. Okay, and we are having the position vector of xi cap plus yj cap and the velocity vector of dr vector by dt, that is equal to d by dt of xi cap plus yj cap, that is equal to dx by dt I cap plus dy by dt j cap. Okay, and the acceleration vector we can write it as d square x upon dt square I cap plus d square y upon dt square j cap. Okay, so let us differentiate this particular expression with respect to time. So we can get d by dt of x square by a square plus y square by b square is equal to d by dt of 1. So here we will get 1 by a square into 2x times dx by dt plus 1 upon b square into 2y times dy by dt is equal to 0 because the differentiation of 1 is 0. So from here we will get 2x by a square into dx by dt plus 2y by b square into dy by dt is equal to 0. And at the location of x is equal to 0, the first term will be 0. So we can get 2y upon b square into dy by dt is equal to 0. So from here we will get dy by dt is equal to 0 at x is equal to 0. Now if we write the velocity vector, that we can write it as dx by dt I cap plus dy by dt j cap. Dy by dt is 0, and the magnitude of the velocity vector we can write it as v. So we will get dx by dt is equal to v. Okay, and let us differentiate this particular expression again in order to find the acceleration. So we will get 2x by a square into dx by dt plus 2y by b square into dy by dt is equal to 0. Okay, so from here we can write 2 by a square into d by dt of x into dx by dt plus 2 by b square into d by dt of y times dy by dt is equal to 0. So from here we will get 2 by a square into x as it is d square x upon dt square plus dx by dt whole square plus 2 by b square as it is y into d square y upon dt square plus dy by dt whole square is equal to 0. Now here the term dy by dt is 0 that we have found out here. So this term will be 0. D square x upon dt square is also 0 because v is constant. So we can write d square x upon dt square is equal to 0. So this particular term will also 0. So we can write finally, and dx upon dt square is v. So we will get 2v square upon a square plus 2y upon b square into d square y upon dt square is equal to 0. So from here we can get d square y upon dt square is equal to minus v square b square divided by a square y. Okay, so this is the expression of d square y upon dt square we got, and d square x upon dt square is equal to 0 because v is constant. Okay, so now here y is variable. So for that, if we at x is equal to 0, we can write x square by a square plus y square by b square is equal to 1. So x at x is equal to 0, we can write y is equal to plus minus b. So basically the value of d square y upon dt square we can get it as plus minus v square b square upon a square into b. So we can write d square y upon dt square is equal to plus minus v square b upon a square. So this is the expression of the d square y upon dt square we got. So let us write the expression of acceleration, that is equal to d square x upon dt square I cap plus d square y upon dt square j cap. Here d square x upon dt square is 0. So we can write the acceleration vector as plus minus v square b divided by a square j cap. And if we write the magnitude of the acceleration vector, that we can get it as v square b upon a square. Okay, so this is the expression of the acceleration we got. Now let us come to the radius of curvature. Again we will use the same formula, that is r is equal to 1 plus dy by dx whole square whole to the power of 3 by 2 whole divided by d square y upon dx square. And in this particular case, the equation given as x square by a square plus y square by b square is equal to 1. And let us differentiate with respect to x. So we will get 1 by a square d by dx of x square plus 1 by b square into d by dx of y square is equal to 1. Sorry, is equal to 0. Is equal to 0. Is equal to 0 we got. So from here we can get 1 by a square into differentiation of x square is 2x plus 1 upon b square into 2y into dy by dx is equal to 0. At x is equal to 0, we can write dy by dx is equal to 0. Okay, let us differentiate this particular expression again. So we will get 2 by a square into d by dx of x plus 2 by b square into d by dx of y times dy by dx is equal to 0. Okay, so d by dx of x is 1, so we will get 2 by a square plus 2 by b square times y times d square y upon dx square plus dy by dx whole square is equal to 0. So dy by dx is 0. So from here we will get y into dy by dx d square y upon dx square is equal to minus b square by a square. So we will get d square y upon dx square is equal to minus b square upon a square y. Okay, and we have found out that at x is equal to 0, y is equal to plus minus b. So we will get d square y upon dx square is equal to plus minus b square upon a square into b. So we will get d square y upon dx square is equal to plus minus b upon a square. Okay, so let us substitute the value of d square y upon dx square here. Dy by dx is 0, so the value of radius of curvature we will get it as 1 divided by b upon a square. B divided by a square, so radius of curvature we will get it as a square by b. We have taken it as positive because radius of curvature is always positive. Okay, so I hope the entire procedure is clear. Thank you.